Hello students, welcome to Senior College Mathematics. Topic of discussion is matrices and determinants. Lesson 10, matrices and simultaneous equations. So it is possible that we solve system of simultaneous equations using matrices, and the rule we want to look at is Crammer's rule. Crammer's rule. Before that, for updates, follow Petakus Educom via YouTube at Petakus Simplified Maths. To do that, subscribe to this channel, like this video, share the video to your friends, your colleagues, your classmates. You can also follow us through Facebook at fb.me/PetakusEducom, Instagram at PetakusEC, Telegram t.me/PetakusEducom, WhatsApp through this mobile telephone number. In all of these platforms, you get updated from time to time about what is happening at Petakus education community, where you have access to quality, unlimited, and simplified mathematics teachings in series. So let's look at the method properly. Crammer's rule, named after Gabriel Crammer between 1704 to 1752. So that is a man that invented this method of solving equations. He uses determinants to solve a system of m linear equations in n variable. So this m talks about the number of equations you have. The n is the number of variables. This rule is applicable only to systems with unique solutions. Not all the system of linear equations that has unique solution. Not all that have unique solution. So the message for you to grab here is that Crammer's rule uses determinants to solve a system of linear equations. Okay? So system of equations in two variables, that is two equations with two variables. All right? So we have this system here, as plus by equal to c, then ds plus ey equal to f. So you have s here. We have two equations with two variables s and y. So to continue, you have to obtain the coefficient matrix of the system of the equation. The coefficient matrix is matrix you obtain using the variables column. For instance, if you take s column, the coefficient of s in equation 1 is a, and of s in equation 2 is d. You see that now? That is the s column. If you take y column, the coefficient of y in equation 1 is b, and equation 2 is a. So this matrix is referred to as coefficient matrix. Coefficient matrix, and the constant matrix is b. The constant matrix is simply the right hand side. C and F, they are constant, they are numbers. You should know that. The above system of equations can be written in matrix form as. So in matrix form, the coefficient matrix is used to multiply the variables s and y, and is equal to the right hand side. that is a constant matrix. This system now is in matrix form. The coefficient matrix multiplied by the variables equal to the constant matrix, that is the right hand side. Okay, so by Crammer's rule, determinant of A, the coefficient matrix, must not be equal to 0. Must not be equal to 0. Okay, so of course from one of our lessons, this is how you obtain determinant. You introduce the symbol of determinants. Okay, now for you to get the solution of the first variable s, the solution of s now, so s is equal to determinant of a sub s. Determinant of a sub s. Now how do you get that? Look at this now. From the coefficient matrix, remember the s column now. The s column here is AD. You see that? Is AD. And the constant matrix is FC. So determinant of A sub S, to obtain it, you replace the S column with the constant matrix. So Y column remains. To find determinant of A sub S, you replace the S column with the constant matrix. You also look for determinant of A sub Y. To get that, this is the coefficient matrix now, but you replace, look at the Y column here, so you replace the Y column with the constant matrix. After doing that, then you can now solve for S. So S is the determinant of A sub S over determinant of the coefficient matrix. To get Y now is equal to A sub, that determinant of A sub Y over determinant of the coefficient matrix. So from here you observe that the denominator of S and Y is simply the coefficient matrix of A of the original system. That is the denominator. You can see that for S and Y. Then the numerator of S and Y are formed by using the column of the constant as replacements. I already explained that. Numerator of S and Y are formed by using the column of the constant as replacements for the coefficients of S and Y in the coefficient matrix. Okay, the two determinants are denoted by A, determinant of A sub Y, and determinant of A sub S. That is A sub S, A sub Y. Okay, now let's look at examples. Solve simultaneously using the Crammer's rule. The Crammer's rule, we have this system of linear equation: 20s plus 8y equal to 11, then 12s minus 24y equal to 21. So solution, you just bring down the linear equation in this form: 20s plus 8y equal to 11, 12s minus 24y equal to 21. The first thing you must get now is the coefficient matrix, and I prefer doing it column wise, where I will take the S column. So the coefficient of S in equation 1 and 2, you have 20 and 12. You see that? Coefficient of Y in equation 1 and 2 is plus 8 and minus 24. you don't ignore minus sign. So you have 8 and minus 24. With this, you have formed the coefficient matrix, and the name is A. Now let's get a constant matrix B. That constant matrix is what I call the right hand side. That is 11, 21. You form them using the order of the equation. 11 is for first equation, 21 is for second equation. After that, you put the system in matrix form. So in matrix form, you have the coefficient matrix multiplied by the variables equal to the constant matrix. So this is the system in matrix form. Are you following? Okay. So first thing we do is to find determinant of the coefficient matrix. That is determinant of A. This is the coefficient matrix. In lesson 7, we explained determinant of matrix of order 2. Okay, and when we said that you take the difference of the product of the two diagonals, where you start with the leading diagonal, that is 20 minus 24 in this form. The difference is minus the other diagonal is 8 times 12. So you have minus 480 minus 98, and that is minus 576. When you are done with that, you look for determinant of A sub S. That is the coefficient matrix alongside variable S. This is coefficient matrix. But what do you do now? You replace the S column with the constant matrix. You see the constant matrix is 11 and 21. So you replace the S column. The S column 20 and 12. You replace it with a constant matrix. So you look for the determinant as well. So this is the main diagonal minus the product of the other diagonal. That is minus 264 minus 168, and that is minus 432. You also look for determinant of A sub Y, whereby you replace the Y column. Y column is 8 minus 24, so you replace it with the constant matrix, that is 11, 21. Then you find determinant by taking the product of the main diagonal minus the product of the other diagonal. So you have 420 minus 132, and that is 288. After that, you now look for A. So A, you now look for S. So S is determinant of A sub S over determinant of coefficient matrix, and this is what you have there. When you reduce, of course, you know if you divide a negative number by negative number, you have positive number. So when you reduce, you have 3 over 4. To get Y, you divide the coefficient of A sub Y. Okay, so to get Y, you divide the coefficient of A, determinant of A sub Y, by determinant of coefficient matrix. So you have this result, and when you reduce, you have 1 over 2. So the value of S is 3 over 4, and the value of Y is minus 1 over 2. If you verify your answer, this is equation 1, where S is this and Y is this. When you reduce that, you have okay, so when you reduce, in first place, you divide 20 by 4, you have 5 times 3 is 15. divide 8 by 2, you have 4 times minus 1 is minus 4, and you have 15 minus 4 is 11. So the solution is correct. Let's take one more example to explain more. Okay, example 31, solve the equation. So here you already have it in matrix form. So in this case, you don't form any other matrix, so you have it in matrix form. So what you do is to give the system a name, where the first matrix is the coefficient matrix, then the variable matrix is mn. You are looking for mn, so let's know the variable matrix as S, and the constant matrix is B. You see that? So after the naming, what do you look for again? The determinant. So you look for 3 determinants. First, the coefficient matrix, determinant of A sub m, and A, that is the coefficient matrix in respect to the variable. So you look for determinant of A, that is 3 times 1 is 3 minus 3 times 0, and you have 3. Okay, you determinant of A sub n, that determinant, the m column, now the m column is 3 3. You replace the m column with the constant matrix, that is minus 6 minus 10. If you find determinant, you have minus 6. Then you look for determinant of A sub n, where you replace the n column 0 0 1 by the constant matrix, that is minus 6 minus 10. Are you getting it? Okay. After that, you look for determinant, where you take 3 times minus 10, that is minus 30. The difference follows. Then minus 6 times 3 is minus 18. You have minus 30 plus 18, because minus is plus. You have minus 12. The next thing is to look for m. And what is m? Determinant of A sub m, that is the coefficient matrix in respect to m over determinant of the coefficient matrix, and you have minus 6 divided by 3, and that is minus 2. Then you look for n as well. And what is n now? Determinant of A sub n divided by determinant of coefficient matrix, and that is minus 12 over 3. When you divide, you have minus 4. So this is how you solve system of linear equations using Crammer's rule. You get the coefficient matrix, you get the variable matrix, and the constant matrix. You put the system in matrix form. Matrix form is simply the coefficient matrix multiplied by the variable matrix equal to the constant matrix, usually the right hand side. Then you look for determinant of the coefficient matrix first. Then you look for determinant of the coefficient matrix with respect to the variables. So the first variable, you replace the column of that variable with the right hand side. The second variable, you replace each column with the right hand side, and you get 3 determinants. Then you divide as we have explained. You get the solution of the equation. Alright, end of lesson 10. Thanks for watching and learning with Petakus education community. Don't forget, watch out for more from the voice of Petakus. The voice you are hearing is the voice of Petakus. For questions and inquiries, use the comment section and we attend to them. For the complete package of this topic, lesson 1 to lesson 11, for offline usage, you can contact the voice of Petakus via this WhatsApp number or through the email address. At a very little token, you get the complete package delivered to you. Lastly, if you are not safe, your life will be in crisis. To avoid that, you give your life to the one that can save you, that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior daily. If you are saved already, I tell you big congratulations. Live righteously and be prepared, because on the last day some will be taken and some will be led. Take good care of yourself, stay out of trouble, study your books, do the needful at all time, flee every appearance of evil, don't defraud others to make money, use your hand and your brain to work genuinely, and the Lord will bless you. Goodbye for now.